Students, now we will look at an example for multi-facility location problem. So in this example, we will look at different approaches for the solution of multi-facility location problems. Now let us look at this example. Let's say there is a company that is interested in building 2 distribution centers to meet the growing market demand. The customer locations are grouped into 4 regions, which are given in the table below. Customer region 1 is located at 3, 8. So the 3 would represent the x coordinate, 8 would represent the y coordinates. And the volume in hundredth of weight, CWT is hundredth of weight, and that is a unit commonly used in logistics, has a volume of 5,000 that can be moved from customer region 1, and the transportation rate per 100 weight per mile is 0.04 or 4 cents. Then there is a customer region 2, which is located at 8 2 location with 7,100 weight as a volume. That is the capacity of that customer region, and the transportation rate per 100 weight per mile is 0.04. Then there is a customer region 3, which is located at 2.5, and the volume, which is of total demand or the capacity for that region, is 3,500 hundredth of weight, and the transportation rate is 0.095. And similarly, for region 4, the location is 6.4, having a volume of 3,000 hundredweight and the transportation rate of 0.095 per mile. So the first approach we will discuss would be the clustering-based method. In a clustering-based method, let M denotes the number of customer regions and N denote the number of new distribution centers. So what we have in this example, M would be 4 because we have 4 customer regions with us. And the distribution centers, as given in the problem, there are 2 distribution centers. So N will be 2 for this specific problem. The clustering model has 2 steps. So in the first step, the M customer regions are partitioned into N groups based on their distance-based proximity. So based on the distance, kitna close hai? Proximity here means the closeness of the customer region. Based on that, the first step would be that जो customer regions हमारे पास मौजूद हैं, we will partition them into N groups. N could be any number, 1, 2, 3, 4, like that. और उसमें customer region fall किस तरह करेंगे? अपनी proximity यानी closeness की basis पर. So the new facility for each group is determined by using the median or center of gravity method. You know about the center of gravity method from your previous course in transportation and logistics management. When the number of new facilities is not pre-specified, appropriate clustering method, which is given by Romsberg in 1984, can be used to determine the number of groups, which will then be equal to the number of new facility needed. In our example, we have M is equal to 4 and N is equal to 2. 2 distribution centers are there, 4 customer regions are there. First, cluster the existing facilities into 2 groups by using the single linkage clustering method with distances as similarity coefficient. Here, the rectilinear distance matrix is used to develop the following distance metric. Okay, from and 2 would be given here. From 1 to 1 would be 0. From 1 to 2 it is 11. From 1 to 3 region would be 4, and from 1 to 4 it would be 7. And from 2 to 1 would be 11, similar like the first one. 2 to 2 would be 0, and 2 to 3 would be 9, and from 2 to 4 would be 4, and so on. So this similarity index would be produced for the given example. Now, based on that similarity matrix, this is actually based on the distance from one region to the another region. What we need to do, we need to go look at the application of a single linkage clustering method that it yields the following two groups. The group 1 would be customer region 1 and 3, whereas group 2 would be customer region 2 and 4. If you see, on the basis of these distances, from 1 to 3, we have the minimum distance of 4. You can just scan this whole matrix, the distance matrix, for the minimum distances. So 4 would be the one which is between 1 to 3. So in one group, I would be putting, for group 1, it would be region 1 and region 3. And then 2 has a proximity with 4. If you see, from 2 to 4, we also have a distance matrix representing it as 4. So that means they are close to each other. So group 2 would be 2 and 4. Now we have two single facility location problems, one with customer region 1 and 3 and the other with region 2 and 4. Basically, the multi-facility location problem actually converts into a single facility location problem, which can be solved by the previous methods which we have studied. So the customer region problem, what would be to have region 1 and region 3. The locations are 3, 8, 2, and 5, which was given in the problem, and the volume and the transportation rates were given in the problem. And the problem 2 would become, the sub-problem 2 would become with region 2 and region 4 with their location, volume, and transportation rates as given in the problem. The optimal location for the new facility to serve group 1 is at region 3, since it will result in maximum saving in transportation cost. And similarly, the optimal location of the new facility to serve group 2 is at region 4. Hence, the new distribution center must be located in customer region 3 and 4. How did we come to this optimal solution? For that, you have to look at the rectilinear location model, which is essentially a single location model. And you can verify that in problem 1, solution region 3 would be optimal in terms of the transportation cost, minimizing transportation cost, because the transportation cost would be lower for region 3. And similarly for problem 2, you can verify it that region 4 is actually more attractive in terms of locating the new facility because of a lower transportation cost, overall lower transportation cost. So the distribution center must be located in customer region 3 and 4. You need to verify the solution. Then we have exhaustive enumeration. For this example, one possible assignment is to assign customer region 1 to new facility 1, and then customer region 2, 3, and 4 to new facilities. Under this assignment, the location of new facility 1 will be the same as the location of customer region 1. The location for new facility 2 can be determined using the median or center of gravity method. Simply, we can take the median of this, or center of gravity method would be more appropriate. Another possibility is to assign customer region 2 to new facility 1 and existing facilities 1, 3, and 4 to new facility 2. So in this case, the location of new facility 1 will be the same as the location of customer region 2. And the location for new facility 2 can be determined based on the median or center of gravity method. So what is this? We are actually looking at every assignment. So that is why the method is known as exhaustive enumeration. So you will assign one by one every region, and then you will look at the best facility. So actually there are 4 possible assignments only, which is given in the table. So assignment 1 would be to assign a new facility to region 1. And new facility 2 would either be assigned to region 2, 3, and 4. So that means new facility would be accommodating the demand for region 2, 3, and 4. Whereas new facility 1 would only be accommodating region 1. Assignment 2 is like new facility would be accommodating region 2, and the new facility 2 would be accommodating the other regions, which are now 1, 3, and 4, and so on. So in this case, these are the 4 possible assignments since distribution center 1 and 2 are identical. We assume that in this example that both distribution centers are identical in terms of their characteristics, like their capacity, their transportation modes. The location for the second distribution center is done by means of the median method. What does it mean? We have a new facility 2. Either we can use for new facility 2, which is for region 2, 3, and 4, or region 1, 3, and 4, or region 1, 2, and 4, or region 1, 2, and 3. What we can use either a center of gravity method or the median method. Median method will give the median value for it, and the transportation costs of various assignments are given in the following table. So assignment 1 would be for second facility location would be for 6, 2, and the total transportation cost would be for that region would be 3457.50, and assignment 2 would be for 3, 5. So you just need to take the median of region 2, 3, and 4. So when you take the median of it and use the same single facility location problem which we have used before in the median method, you will find the coordinates 6 and 2 for the second location. And that second location would be actually serving your region, let's say for the first possible assignment, region 2, 3, and 4. So the second facility location for the first assignment for region 2, 3, and 4 would be located at 6, 2, and the total transportation cost would be 3457.50. In the similar fashion, for the other 3 assignments, we will find the second facility location by a median method and find the transportation cost for it. So the optimal location for the 2 distribution centers are 8, 2, and 3, 5. And region 2 should be assigned to the first distribution center at 8, 2, and region 1, 3, and 4 to the second distribution center at 3, 5. Why? Because if you see the above table, the point is the second facility location should definitely go to assignment 2 because it has a lower cost. The first assignment for second facility location gives you a cost of 3457.50, whereas the least cost is for the assignment 2, which is that means the second facility location should be located at 3, 5 with a total transportation cost of 2072.50, and it should be located at 3, 5. Similar to, you need to calculate the cost for the first facility location, which was done in the first enumeration. So in this example, in this method, you would see that there are exhaustive enumerations need to be done. And if we have more assignments with us, it becomes complex. So it is only possible if you are doing it by hand, then for a small scale, that means like 3, 4, 5, 6 assignments, you can do it. But for more assignments, it becomes very hectic. So students, we have seen 2 methods here. One was clustering based, which is actually very common and more practical in nature. In clustering based method, you need to first of all determine the cluster, and after determining the cluster, the multi-facility problem actually changes into a single facility problem. We know how to solve a single facility problem. So once the multi-facility problem changes into a single facility problem, we can find the solution of those problems to get the overall solution. The second method was about exhaustive enumeration. That method is not that common because if your combinations, if your assignments are more than like 5, it becomes cumbersome. So in that, you need to follow every assignment. You need to exhaust every assignment which can be done. And after that, you will be using either the median method, which is actually quite easy, or the center of gravity method in order to determine the total transportation cost and the location of that distribution center that needs to satisfy the demand of 2 or 3 different locations. So these were the 2 important methods which we discussed for the multi-facility problem. Thank you.